you're going to create a profile of deprivations for each individual or for each household, depending on your own particular measures. And then you're going to know, for example, that some household is deprived in 20% of the weighted indicators. Some other household is deprived in 30% of the weighted indicators. Others are deprived in 2/3 of the weighted indicators, or 67% roughly. Now, when I set the k-value, when I say that the k-value is equal to 50%, it means that to be identified as multidimensionally poor, the individual or the household would need to be deprived in 50% or more of the weighted indicators. If a household is deprived in 30% of the weighted indicators, then they are non-poor. All the household members will be non-poor. If the household is deprived in 80% of the weighted indicators, then all the members of that household are going to be identified as being multidimensionally poor. Is that clear to everyone, or there is still some doubt, some little bit of questioning or doubts that we haven't really been able to eliminate? Clear for everyone? I think that 10 people replied to that question. Is the rest of the is it clear what the k-value is, yes or not? Yeah. Okay, good. Now, what is the M0 or the MPI? When you present your own MPIs, what you are creating with your groups, what is it that you're going to present? What is it that you're going to say? Going one step back first, when you present the MPI, or if somebody on the street asks you what's the MPI, well, probably nobody on the street would ask you what the MPI is, but let's imagine that we run into someone on the street and it's very eager to know what you were doing in your summer. And you say, well, I went to this amazing summer school in China, I learned about the MPI. So they tell you, well, what's the MPI? Well, the MPI, it's the multidimensional poverty index. It's basically an index of poverty that considers that an individual or a household can be deprived in many dimensions at the same time, and it's based on the Alkire-Foster method, right? It's one particular application or one particular example of the Alkire-Foster method for once you have already decided on a particular set of dimensions or indicators that are important, that have intrinsic value, and that's why we're including them into the MPI. But it's absolutely true that when I have a particular value for the MPI, for example, if I say that the MPI is 0.111, that means that the poor are deprived in 11.1% of the deprivations, the total deprivations that would exist if everyone in the population was deprived in everything at the same time. So if this is my population, this classroom is our population, if all of us are poor and we are deprived in everything at the same time, what's the value of H? What's the value of the incidence of poverty? If we are all poor here, what's the value of H? 1. Perfect. Now, we are all poor, and we are all deprived in everything. So what's the value of A, the intensity of poverty? 1. Then if everyone in the population is deprived in everything at the same time, what's going to be the value of the MPI? 1. So that's one of the extreme values of the MPI, 1. When everyone is deprived on everything simultaneously. And as you were perfectly mentioning before, the MPI represents what's the share of deprivations, the proportions of deprivations that the poor are facing out of that 100% that would happen if all of us were deprived in everything at the same time. So that's the perfect interpretation of the MPI. Very good. Now, the next thing is H. I've already mentioned this in my explanation, but who can tell me what H represents? If I tell you that H is equal to 10%, how would you read that 10%? Anyone? I'm going to start cold calling.
10% of the population
Who's somebody speaking, but I cannot see you. Okay.
Yeah, I was saying 10% of the population is considered multidimensionally poor.
Perfect. Age is the incidence of poverty. It's the proportion of people that are identified as being multidimensionally poor. Now, which parameter is going to be key in identifying people as poor or non-poor? What do I need to decide on first so that I can go from individual information to age? The poverty cutoff. Because even for the same population with the same poverty or the same deprivation profile, for different values of K, for different poverty cutoffs, I'm going to get different values of K, of age. So if the K value is 10%, some of you will be identified as multidimensionally poor. If the K value changes to 20%, I'm going to get a different proportion of people that are multidimensionally poor. Now, what's the relationship between K and age, which we saw the other day, we saw yesterday on Stata? What happens with the incidence of poverty at K as K increases? It decreases, exactly. If I become more demanding and if I require that people need to be deprived on a larger proportion of weighted indicators at the same time to be considered multidimensionally poor, the proportion of poor is actually going to decrease. Good. Now, who can tell me what A is, the intensity of poverty? Perfect. Is the average deprivation or the average proportion of weighted deprivations among the poor. It's very important, this detail that you added at the end. Among the poor, we are focusing on the poor. We were trying to understand how poor they are. And this is the real value added of the methodology. Because now we are not only looking at who is poor and who's not, but we are actually adjusting by how poor they are. This is the real novelty of the methodology. Great. Now, who can tell me what the sensor head counts are? And Anna was just revising that on her session as well. What's the sensor head count, for example, of water or assets? I'm looking who I'm going to choose.
It's the proportion of people who is deprived and poor.
Exactly. Exactly. Remember when we yesterday did this box that was the population and the two different sets? One set for those that are multidimensionally poor and the different set for the people that are depriving water. Not everyone that is depriving water is going to be multidimensionally poor. And similarly, not everyone that is multidimensionally poor is going to be deprived in water. They could be deprived in other things and not in water. But as Carla was saying, the sensor head count for water is the proportion of people who are depriving water and multidimensionally poor. And this is a proportion that we obtain out of the total population. Remember that the denominator is N, is everyone in the entire population. And as we saw yesterday, this number, can it ever be equal to the uncensored head count? The censored and the uncensored head counts, can they be the same or not? They can be the same. When? In the union approach. Perfect. Because in the union approach, everyone that is deprived in at least one thing is multidimensionally poor. And therefore, the set of people depriving water is going to be included, is going to be part of the larger set of people that are multidimensionally poor. So everyone that is depriving water is already multidimensionally poor. In that case, the uncensored and censored head count ratios for water are going to be the same. Now, can the uncensored head count ratio for water ever be above or higher than the uncensored one? The unsensor, can it be above the sensor or higher than the sensor? The sensor higher than the unsensor? No. Okay. I was mixing it, so it's obvious that it was not possible for you to answer. Very good. And what's the percent contribution of each indicator? What does it mean? What is that? If I say, for example, that the percentage contribution of water, to go on with the same indicator, is 25%. What does it mean? It means that water makes up for 25% or contributes 25% to the overall MPI. That's the exact definition. Now, if I have 4 indicators, like in the example that we're doing in Stata, and I add the contributions up, so I do contribution of water plus contribution of assets plus contribution of nutrition plus contribution on schooling. What is that sum going to be equal to? 1 or 100%. Because at the end, when I add up all the contribution for all the different indicators, it needs to give me 100%. Basically, all the indicators together give the value of the global of the overall MPI that we are computing. Very well. Okay, and basically, this is just clarification, but if you decided to use different K values, you would be able to create different measures of MPI, or different MPI based on how demanding you are with the poverty cutoff. For example, in the case of the global MPI, the one that we use more, that we talk about the most, is the K value of 1/3. But we actually use 3 different K values. We also use the K value of 20%, and we use the K value of 50%. And we report figures on all those K values. And we say that people that are deprived in 50% or more of the weighted indicators in the global MPI are considered to be living in severe poverty. They are deprived in at least half of the 10 indicators in the global MPI. So they are suffering from severe poverty. They are suffering from more deprivations than just the regular MPI with 1/3. And then we say that people that are deprived in between 20% and barely below 1/3, so between 20% and 33.29999, we just say that they are vulnerable to poverty. They are not poor because they are below the 1/3, but they are close enough that if their situation changed, they could easily become multidimensionally poor. So we consider them as vulnerable. In some of the countries that we work with, they have done something similar. Pakistan, for example, they launched their national MPI the 20th of June this year, after being working on it for a couple of years. And they have 2 different poverty lines. They have a poverty line equal to 1/3, but they also present a second poverty line equal to 50%. And they talk about multidimensional poverty and intense multidimensional poverty. Something similar is being done in Ecuador. They also launched their MPI this year. And Paraguay, who is about to launch, they're also going to do this, or they are thinking maybe even 3 lines, something similar to this. So as you can see, even playing with the K, you're going to get even more things that you could exploit and analyze out of the measures that you are creating with your groups. Okay, so basically that previous slide, or that slide was just a very brief just revision of all the terms that we have seen so far. The idea here is that I want you to explain me each of the following sessions. I'm tired, so I just want you to tell me what it is that we have here. Just to make sure that now we go from the previous slide, which is just more general, to the actual detail behind the underlying the methodology. Okay, because this is the pillar of everything else that we are going to be doing on the MPI. Perfect. Then, the next, once we have the achievement matrix and the deprivation cutoff, the next thing is to be able to say who is deprived in each of the different indicators. So let's just do one indicator, and the rest it will be exactly the same. So for example, in the case of income, I'm saying that the minimum level of income that an individual needs to have to be considered non-deprived is 500. Who's going to be deprived in income and who's not deprived? Second and third are deprived, and 1 and 4th are not. Good, because they have levels of incomes that are equal to or above 500. Very well. Now, what am I going to do with that information? How do I go from this? What's the next step, basically? Yes?
Let's say if we say deprived is 1 and then deprived is 0.
Yes.
So we transform this matrix.
Perfect. So, for people that are deprived, we're going to replace the achievements by 1. And for people that are non-deprived, I'm going to replace the achievements by 0. I heard someone over here saying censor. We are not yet censoring anything. To censor, we need to choose the k-value, and that happens later. At this point, the first thing that we are doing is simply replacing the achievements by 0 and 1, identifying the different deprivations for each individual. Now we already have then this, that is the deprivation matrix. We went from the achievement matrix to the deprivation matrix. Now what's the next step? What do we do now? Weight. I don't know if I actually, I have weights or weights. So now I'm just assuming that I'm giving a weight of 1/4 to each of the different indicators, and to keep it simple, right? That's what we are doing. Great. So now we have the weighted deprivation matrix. What's the next step? We need to add the vector at the end, the counting vector with the proportion of deprivations that each individual is facing, right? Basically, we sum for each individual all the rows, counting what are how many deprivations they are facing. So for example, in the case of the first individual, what's the value of that vector? 0. He's deprived in nothing, 0% out of the total indicators. What's the situation for the second, for the second individual? 5 or 0.5? 0.5. 0.5 or 50%, exactly. He's deprived in 50% of the weighted indicators, or 0.5. And the same for the other 2 individuals. So basically, we are just adding that vector at the end of the matrix. Now, from here, what's the next step? Who is poor in this society? We're missing the poverty cutoff. The k-value needs to be defined. So if I use the union approach, what's the k-value? 1. And then if I use the union approach and the k-value is 1, what's the proportion of people that are multidimensionally poor? 3 out of 4, 75%. Perfect. Who are the people that are poor in this society if I use the union approach? Yes, 2nd, 3rd, and 4th. The only person that is non-poor is the first one, because he's not depriving anything. That's the only way in which you can be non-poor on the union approach. Is that clear? Yes, great. Very good. Now, if I use the intersection approach, how many people, first of all, what's going to be the k-value in the intersection approach? It's going to be 4 indicators, or in this case that it's already weighted, 1. Which means that the individual needs to be depriving 100% of weighted indicators. 4 indicators or 100% of deprivations. In that extreme case, how many people are multidimensionally poor? 1. Number 4. John is the, sorry, me. Oh my God. Well, it was very generous of me to add my own name in that row and not put, I don't know, Monica or Gisela. You see, I'm nice. Okay, so I'm the only multidimensionally poor in this society because I'm deprived in everything at the same time. Now, we know that the Alcayer-Foster method, the dual cutoff methodology, actually allows you to choose not only these extreme cases, but any k-value that is between 0 and 1, or between 1 indicator and the total number of indicators in the measure. So let's assume now that we are choosing a value of, well, we just added a different intermediate values of k at the end. So for example, we use a k of 30% and a k of 60% beyond the one of 100% that we were discussing just now for the intersection approach. Now, in the case of 30%, we are asking people to be deprived in the case of 30%, we're asking people to be deprived in at least 30% of the weighted indicators to be considered multidimensionally poor. So in that case, who are poor in this society? Who are going to be poor if we have a k of 3, say of 0.3? The second and third people in the row, exactly. So what's going to be the head count? Half. 2 out of 4 or 50%, exactly. Half of the society is multidimensionally poor. And then just similarly, if we require that people need to be deprived in at least 60% to be multidimensionally poor, we are just left with one person, with me, as being multidimensionally poor. And so the headcount ratio, the incidence of poverty, is going to be 1 out of 4 or 24%. Good. So now we've already got to this point in the matrix. We have the counting vector, and we have the proportion of multidimensionally poor or the incidence of poverty for different k values. What is the next step? We censor the matrix, exactly. For any particular value of k, we need to censor the matrix. What does it mean to censor the matrix? So for example, if we choose the value of k of 30% over there, and so we said that just I think it was, what are the names? Chris and me, that we are multidimensionally poor. Then what does it mean that we're going to censor the matrix? Exactly. We replace the ones of the non-poor by zeros. So for Anna, for the first person in the matrix, is there anything that's going to change? No. Anna already had all zeros. Good. And then for John, for the last person in the matrix, is there anything that's going to be censored? Yes. So what is going to be censored in this matrix for John? The deprivation on education. We are going to replace that 0.25 by a 0. We're going to censor that information so we can focus on the poor and go on with the computations. Let's assume that we have a 0 over here, okay? So that John has already been censored. So once that we already have the information for me and for Chris, who are the people that are multidimensionally poor with a k of 30%, how do we compute the A? How do we compute the intensity of poverty? Like you correctly said before, intensity is the average proportion of deprivations among the poor. So the poor in this society is just me and Chris, the second and the third row. How do we compute? And I am deprived in everything, and Chris is deprived in 50% of the indicators. So my share of deprivation is 100%, and his share of deprivations is 50%. So how do we compute A? What do we do? We take the average, exactly. As the definition itself says, the intensity is the average proportion of deprivations among the poor. So if my proportion is 100% or 1, and his proportion of deprivations is 0.5, to get the average proportion of deprivations, we basically take the average between 1 and 0.5. So then the intensity of poverty for us is going to be just 75%. If we were using a higher k-value, if we were using a k-value of 60% or 70%, that would make me the only poor person. How do we get the intensity of poverty? It's 1. Because I'm basically, if I'm the only person that is poor, the average proportion of deprivations among the poor is going to be equal to my share of deprivations, because I'm the only poor. So it's going to be equal to 1. Perfect. So now, the next step is that we already know that with 30%, half of the population is multidimensionally poor, and that the A is 75%. The next step is simply to compute the M0, which is just the product of intensity times incidence. So it's just 50% times 75%. And that is what we have there. The M0, the MPI, is 0.375. Now, what's another way in which we could have computed the M0? Rather than multiplying H times A. It's the average deprivation, it's the average of the sensor matrix. So once we replace this by a 0, if we take the average of the sensor matrix, that's going to also be equal to 0.375. So if we do 0 plus 0 plus 0 plus 0 plus 0.25 plus 0 plus 0 plus 0.25, and so on, and then we divide everything by 16, we have 4 people and we have 4 indicators. So that's 16, the denominator is 16. Oh yes, sorry, divided by 4. Divided, yes, normalized, divided by 4. Then we get that the average of the whole matrix is 0.375, which is the same that we get if we do H times A. And yet another way in which we could get the M0 would be if we take the average of what? The sensor counting vector. So we have this vector with orange over there is a counting vector. Now if we censor the information for John, because he's not multidimensionally poor, and we put a 0 there, if we take the average of that vector, 0 plus 0.5 plus 1 plus 0, and we divide to take the average, in that case, we will also get 0.375. Okay? This comes directly from, basically the counting vector is just adding the rows of the matrix horizontally, which is the same that we would have done for to get the average of the whole matrix. In the do file, that's exactly what we are doing. To compute the M0, we are taking the average of the sensor deprivation vector. That's what you are doing in the do files with your groups. Good. So with any of those 3 alternative ways, either making H times A, taking the average of the sensor deprivation matrix, or taking the average of the sensor counting vector, with all those 3 ways, you get always the same result for the M0. Now, well, finally the sensor matrix appeared here. Good. Now, what is the sensor headcount ratio for years of education? 1 out of 4. Exactly. And what does it mean? That number. Yes. So we have 1 person out of 4, or 25% of the sample, of the population, that are deprived in years of education and multidimensionally poor. So again, I know that I'm repetitive, but we just need to make sure that this is very clear, because these are very common things to get mixed up, how to interpret each of the different elements. So here we have computed the sensor headcounts for each of the different indicators that we have in the in this particular example. If you remember, in the case of John, he was deprived in education, but we censored this information by a 0 because he's non-poor. So in his case, in that particular case, what we would have found is that the uncensored headcount for education would have been what in comparison to the censored headcount? We have now that 1 out of 4 people are multidimensionally poor and deprived in education. In the uncensored headcount, in the uncensored matrix, in the deprivation matrix, the original deprivation matrix, we were showing that John is deprived in education. So what is the uncensored headcount ratio for education? 2 out of 4. So again, this is yet another example of how the censored headcount is usually going to be, unless that we use the union approach, is going to be below the above the censored headcount. Good. And yet here we present another way in which you can compute the M0. And this is actually, these are all things that you already used when you were working on the Alcayer-Foster exercise on paper. You had to use all of this information to get the different things that you were asked to do. The M0 can also be obtained directly from the censored headcounts, right? So it's the weighted sum of the censored headcounts, where we are simply adding the weight of each indicator, right? And now, if I want to get what's the contribution of a particular indicator, what do I do? If I want to get the contribution of years of income, for example, to the MPI, to M0, how do I compute that? It's going to be the censored headcount times the weights over M0 divided by M0. So in that case, I'm going to be computing what's the proportion of M0 that comes directly from deprivations in income. Okay? So that's what we are doing here for each of the 4 indicators. We compute the contribution of income, years of schooling, and so on. And again, like we mentioned before, the sum of all these percentage contributions has to be equal to 100%. Because all the indicators jointly need to adapt to the MPI. Okay. Now, this is just going again to the example of the global MPI to make sure that all of these things are very much understood. So again, in the global MPI, we have 10 indicators that belong to either one or of 3 different dimensions that we are considering: education, health, living standards. For each of the dimensions, we are assigning an equal weight of 1/3, and then each indicator within dimensions also receives an equal weight. So that means that we're using nested weights. For each individual for each household, we create indicators and a profile of deprivation for the 10 indicators. And here we have a particular example that came from a field visit that Buba did in his country, in Cameroon. So basically, we created a profile for Natalie based on the 10 indicators, that the answers that she gave about these 10 indicators on the global MPI. Now, the indicators that appear to be colored in that graph on the right are the ones in which she is above the deprivation, she's below the deprivation cutoff. So those are the indicators in which she is deprived. So these indicators over here, all of these indicators are showing deprivations in the case of, I'm sorry, this is Grace, I mixed up the name. Okay, so what we can see is that in her particular case, she is above the poverty cutoff of 1/3 of the weighted sum of indicators, and so she's identified as being multidimensionally poor. This is the general structure of the global MPI. We go from the 10 indicators of the 3 dimensions to creating a profile for each individual, and then from that, what we do is compare the individual the individual counting vector for each individual against this k-value of 1/3 to identify who's multidimensionally poor and who's not poor. And we do that for each individual in our sample. Then again, we aggregate that information to go from the individual profiles to the aggregate results for each country. We compute the incidence of poverty, which is the proportion of people that are deprived in at least 1/3 of the indicators, and the intensity of poverty that we have already been revising, that it's the average proportion of deprivations among the poor. And then the MPI, the final MPI for each particular country, comes out of the product of H times A, incidence times intensity. So we don't look only at the proportion of people that are poor in each country, but we adjust that by the average deprivation, the average proportion of deprivations among the poor, or the intensity within that country. Now, presenting the global MPI in the same structure of the matrix that we were looking at before for 4 individuals and 4 indicators, in this case, we could still have the same 4 individuals that we had before, Anna, Chris, me, and John, but instead of having 4 indicators, we're going to have 10. We're going to have first indicators on education. Sorry. The first column, for example, could be child school attendance, the second one, years of schooling, then the 2 indicators for health, child mortality and nutrition, and then the 6 different indicators of living standards. Here we are assuming a particular profile for the 4 individuals that we are considering. So, for example, the second individual that in the previous example was Chris, he's deprived in all 4 of, in the 2 health indicators, the 2 education indicators, and in 2 of the living standard indicators. So in total, he's deprived in 6 indicators, but they have different weights. I am deprived in 1 of the educational indicators, 1 of the health indicators, and in 4 of the living standard indicators. So I'm also deprived in 6, but my profile is different because I have more deprivations on living standard indicators that are receiving a lower weight. And then finally, we have the example of John. He's deprived in 1 of the health indicators, for example, and in 5 out of the 6 living standard indicators. So that's a particular example that we are putting together here. The counting vector over there, right next to the matrix, is showing us what's the proportion of the sum of deprivations that each individual is facing. So for example, Anna is deprived in 77.6% of all possible indicators. I am deprived in 55.3. So even though Anna and I are both deprived in 6 indicators, our profiles of poverty are different because indicators do not receive the same weight. And then again, John, he's also deprived in 6 indicators, and he's getting an even lower value in the counting vector because he's mostly deprived in living standard indicators. Now, in the case of the global MPI, as you know, we use a k-value of 1/3. So you need to be deprived in at least 1/3 of the weighted indicators to be considered multidimensionally poor. So how many of these 4 people are multidimensionally poor? 3, right? Anna is the only person in this example that is not multidimensionally poor because she has a share of 0. But then Chris, John, and I, we're both way above 1/3 of deprivation. So we are all multidimensionally poor. So then what's going to be age, or the incidence of poverty? 3 out of 4, or 75% of the population is multidimensionally poor. The next step would be to censor this matrix. But in a way, this matrix is already going to be equal to the censor matrix, because the only person that is non-poor, Anna, is not deprived on anything. So we don't actually need to change anything from the matrix. So then my deprivation share is 55.3, John's is 44.2, and Chris is 77.6. How do we get from that information the average intensity of deprivation among the poor, or the intensity of poverty? What do? We're going to take the average of these 3 numbers. The average of my own deprivation share, because I'm poor, John's, and that of Chris, because the 3 of us are poor. We're going to add up those 3 numbers and divide by 3. We're going to take the average out of our own individual deprivation shares. We're not going to add a 0 for Anna. Why? I'm sorry? I'm sorry, I cannot hear you.
It's not the amount what deprived of any dimension.
Exactly. Anna is not multidimensionally poor. She's not deprived in any of the indicators. So we're not going to take her into consideration. We're not going to add the whole counting vector, but only the figures for the 3 people that are multidimensionally poor, and average only those 3 figures. Okay? If the 4 of us were multidimensionally poor, we would average the whole vector. But only 3 people out of 4 are poor, so we only look at the poor to compute the intensity of poverty. That's what we're doing over here. We are adding up the individual values and averaging by 3, and so we get that A, or the intensity of poverty, is 59%. That means that the poor, the 75% of the population that is poor, is deprived on average in almost 60% of weighted indicators, which is it means that the 3 of us, the 3 people that are multidimensionally poor, we are deprived in around 60% of the weighted indicators. Now the MPI is simply the multiplication of these 2 components, incidence times intensity. That is the last thing that we are doing here in this particular example. Now this is the case of a particular country. We have here the H and A for Nepal, and the MPI for the particular country. And then we also compute what Anna was presenting before for changes over time, so that we are able to compare. Here, who can tell me what happened in 2011 in comparison to 2006? What happened in Nepal in these 5 years? The intensity of poverty decreased, yes. That's because you can see here that in this particular, in the vertical axis, now we are further down, yes. And what else? And the incidence of poverty also decreased. Exactly. So we know for sure that multidimensional poverty has gone down. Both the intensity and the incidence of poverty have dropped in Nepal from 2006 to 2011. and 11. Now, the same type of comparisons could be done by regions within a country. So you're only given 1 year for your countries, but you could have, for example, an analysis for different regions. And so if we have a region in which we find that their bubble is coming in this direction, like it happened in Nepal in 2011, you could claim that multidimensional poverty has reduced. Of course, here we are not presenting robustness tests and standard errors and all of that to see that this change is actually statistically significant. But assuming that it is, the important thing is to know how to interpret these kind of movements in the graph. And this is what we find in the real numbers. You see that both the intensity and the incidence of poverty dropped in these 5 years. And as a consequence, the MPI is also dropping between 2006 and 2011. And here we are just presenting the values for different countries within South Asia, basically. And what we get is that, again, we can prepare a graph like this, either for the same country over time, or for one particular period of time, for different regions within a country, or for different countries, and be able to rank them in terms of both incidence and intensity of poverty. Here, for example, we can see that Nepal is an intermediate level within the region. It has a much larger level of poverty, much higher poverty than Maldives, for example, or Sri Lanka, but it's way below Bangladesh or India in terms of the proportion and the incidence and the intensity of poverty. But also, it's important to consider the years in which these numbers are computed, to be able to make a more or less robust comparison. Okay, we've already discussed what the sensor headcount ratios are, so I'm not going to go again into that. This is a particular example for people that are from Nepal, but okay. And here again, just to show you the decomposition at for different regions in the country, and how this is something that you could be doing in your own particular countries in order to analyze inequality, even inequality within the country. Like, for example, even though the country could be in this situation, or this is probably the bubble that for the whole country, what we find is that when we break the bubble by regions within the country, there is a lot of inequality, a lot of regional disparities. And we go from regions like Western Hill or Central Hill over here, which a level of incidence of poverty around 30%, to values much, much higher in Western Mountain that are even above 70%. So they have more than double poverty, the incidence of poverty in some regions compared to others within the country. So that's why we go over how to break down and disaggregate the figures by subnational and get subnational estimates, so that you're able to get a much more precise picture of poverty within a country. Yet again, when we are analyzing changes over time, we can also analyze both how each individual indicator perform over time, so that we don't just look at the fact that incidence and intensity decrease over time, but for example, in the particular case of Nepal, we know that the living standard indicators were the ones that show the largest improvements in the 5 years that we are analyzing. Even though all indicators improved, the living standard indicators were the ones that really drove the measure down in a way. And then again, for each of the different regions of the country, we can also analyze not only their particular levels of reduction, but which were the indicators, the particular indicators that drove poverty down in the period that we are considering. And even though some trends might be constant for all the regions, we can see that there are particular areas that have been specifically very successful in particular regions, while other areas might have not achieved so much success. Okay, this is exactly the same, but just to compare different countries. I don't want to keep overstressing the same things. But in any case, you have all these slides with all the examples. Now, just to finalize, it's the communication of the MPI and the communication of your results is key. It's something that is very important because it can go from looking at something very complex and very impossible to understand to something that is actually quite informative. But in order for it to be informative, you have to present it in a very clear way and also share all of this information that could be useful. Not just present the MPI on its own or just a combined number that it's aggregated on all the information, but actually really exploit these possibilities that you have to disaggregate and to break it down by indicator, by subgroups, and so on, so that you get the most out of the methodology. Now, in the case of your particular countries, you're going to have to make a presentation on Friday in which you're going to be telling us a story. The idea for you is to try to explain why the indicators that you chose were the ones that were the most relevant for your own countries, but also that to try to explain, for example, like in particular I'm going to take just the case of Sudan. A lot of the countries that are working with Sudan have emphasized the fact that it's a country going through a very clear political unrest, and that has had a huge impact on the quality of life of people living in the country. So that is something that is certainly going to be affecting each one of the indicators that are going to be going into the measure. But at the same time, the different groups have also emphasized that this problematic within the country has not affected all the regions in the same way. So the fact that you are able to get and to show us disaggregations by region and to try to understand these, the historical and political factors within the country through these numbers is also very relevant. So it's important that you don't just present the number and tell what's the proportion of people that are poor and what's the proportion of people that are non-poor or are depriving one indicator, but that actually try to understand what it means and how it can be explained by the stories within the country. So that's why I insist on this part of the communication, to try to give relevance and to explain why the indicators that you chose are informative to the particular problems that a country might be facing. Again, all the other countries working with Vietnam, for example, were emphasizing how agriculture and the environment is key for their economic activity and for growth within the country. And that basically provides a very normative and conceptual basis for why many indicators could be included into the indicator that they are, into the index that they are creating. So all of that is crucial, and that's why we also emphasize on the importance of reading the reports and trying to understand the context of the countries that you're working with. Because this is, at the end, the idea of this exercise is for you to learn the methodology, but whenever you apply this to your own lives and your own professional experiences, it's not going to be just a merely academic or an exercise, but you're actually going to be using this probably for a particular use. And for those working in the government or international agencies and so on, it's going to be an even greater need for clarity in the communication.